All right, so yes, we are starting into right triangle trig, so it's going to be a lot of review today. Do you guys want to try these on your own and kind of see how you can do on them? All right, so you need to solve for A, B, and C. All of the variables. You need to solve the whole triangle. Now, before we start doing, and don't touch the stickers quite yet, because there's a whole method to my madness. And apparently, it doesn't make a whole lot of sense, because I had to put stuff out of order, but it will eventually make some sense. But you will need scissors. The answer button, second negative. All right, so what are we thinking? Okay. Just start pulling like a shin leg hair every time you get lippy like that. I was going to say, how do you think I used to keep my younger brother in line? He's got 100 pounds on me. You just go for an armpit hair. Bless you. All right, we ready? Children, yes or no? Yeah. Okay. So we're going to start with the Alpine Hotel. So if you notice on your little sticky sheet, it's got a line down the middle. That's because there's two little skinny things, but I needed to actually move it so that you guys could get everything printed on one slip. So you're going to have to cut that first sticker in half. Yeah, you're going to need the second, well, no. The second slice off that first one, you're going to need it later, so I would just stick it back in that little slot. All right, ready? So you just need the Alpine one. You got to cut it in half. You'll need the other half of that script. Yeah, I could have run to Staples second period to go get more because I thought I bought more than one box. I did not. The other half, we're going to need it for later, so just stick it off to the side. All right, so you are out hiking. You're at this Alpine hotel, and you're going to take a trail from the hotel up to an overlook. And I struggled really hard to say overlook in first period today. Yes, it is. All right, so they tell me that the hotel has an elevation of 8,000 feet above sea level. Do I really need that 8,000? No. They tell me that the overlook has a height of 11,100 feet above sea level. Now do I need that 8,000? All right, so what's the difference between that 11,100 and the 8,000? Yeah, 3,100 feet. All right, they tell me that the trail itself has a length of 14,100 feet. Now, what they're trying to get to is the angle of incline. That's this little theta in here. So the reason they're trying to get to that is, have you guys ever noticed when you're driving, there will be signs that'll say steep grade, especially if you go up and down mountains? Has anyone ever driven up or down a mountain? Yeah. The reason everything's maxed out at a 6% grade is because semis can't get up and they can't slow down. So they actually have runoffs for semi-trucks or people towing like RVs and stuff when you're going downhill on a mountain. So you have somewhere to go other than careening off the side. Because this isn't Bloomington. You don't live. All right. So we need to figure out what is the angle of that incline. How do you guys think you would do it? Inverse what? Sine. So theta equals sine inverse of opposite over the hypotenuse. 12.7. Which is quite steep. May not seem like it's super steep. It'll feel super steep. Bueno? Alright. Up next, we've got a lighthouse. Alright, now you can place that sticker. The lighthouse sticker. Not the hat. Just the lighthouse sticker. How much space you got? Oh yeah, that'll be fine. Alright, so there's a lighthouse on a hill. What does a lighthouse do? Shines light, exactly. So, what they're trying to do is they're trying to figure out if you can actually see the light from the lighthouse 26 miles away. Now, why do you think they gave us the radius of the Earth? What shape is the world? It's got a curve. So, the problem, well, first period I had to remind them that the Earth is round. They were like, what? It's not flat? I'm like, no. Christopher Columbus proved this a long, long time ago. Sorry, guys. All right, so essentially what we're doing is you've got your little lighthouse. I'm going to draw our lighthouse over here. It's shining light. And I want to see if I could be 26 miles away and still see that light. All right. Here's the radius of the Earth. Well, they gave me the radius of the Earth. Now, they also gave me how high the lighthouse is off the ground, but they told me that, okay, yeah, it's on a hill, and the lighthouse is 117 feet tall, but they told me that the beam of light itself is 362 feet above sea level. So do I even really care about the height of the rock? The height of the rock is 254 feet, and the height of the lighthouse is here. No, I don't even care. This is just extra crap to throw you off. But I care where the light's coming out. I don't care about the height of the lighthouse. I care about the light. Not the tippy top. A lighthouse is actually shaped kind of like this. So you've got this rounded part, this part. You'll occasionally have like fencing, kind of like this. But your light bulb itself is in here and it shines out. And then this is what you see above sea level. Be honest, that's a great lighthouse. All right. So I don't care how high the lighthouse is. I care where the light comes out from. Because this is all just excess crap. The light does not shine out from up here. Sorry. I say this as somebody whose family is obsessed with lighthouses. So, the 362 feet that they give me is how high the light is above sea level. Pythagorean theorem. Now, here's the problem. Feet and miles. So, yes, there is. I need to see if this part here is 26. I don't know yet. Now remember, there are 5,280 feet in 1 mile. Now, do we want to go down to feet and then convert it back to see if it hits miles, or do we want to convert down to itty-bitty, teeny-tiny? You want to do 362 divided by that? So 362 divided by 5,280 gives me a super teeny-tiny decimal. So my hypotenuse itself is 3960.06856. We'll call it 1. I did the 362 feet divided by 5,280 so I could get it in terms of miles. Yes. You want to convert these to feet. No, these are in miles, honey. It's less than a mile to the center. No. We're sticking with miles. All right, so this is my hypotenuse with the little, like literally this decimal point is the height of the light coming off the sides of the earth. Yes, I just flipped it. So I took it and I went like this. All right. And then you add it. You just add it to this. All right. So the bottom is the 3960 down here. So I personally would do Pythagorean theorem on this. But I would try to do it all in my calculator at once. So if it's me, I'm going to do square root of 3960.0685661 squared minus I just did Pythagorean theorem, but I did it all in one. Can I talk, please? Thank you. So you're asking why I did this? This is just going to get me that missing side. But I think it's 26. They're asking us to verify the accuracy of the statement. So I got to prove that it's 26. It doesn't have to be 26. Yeah. So it's actually 23.3 miles. So there's a bunch of different reasons. Think about the fact that this lighthouse has been there since 1846. What happens? Depression? Erosion of the earth. Depression. That's depression.
No, there's another word that I'm thinking.
Depreciation?
Yes.
That's when you lose value on a car.
Oh.
So, yes, you eventually, like, if you think in terms of just anything on the face of this planet, everything starts sinking if it's been there for a certain amount of time. Water gets under the soil, it will start sinking. Human beings, you will start shrinking because of the Earth's gravity on your body. Eventually, same thing with that lighthouse. It could be shrinking. Maybe 150 plus years ago when it was built, it was like 10 feet taller than it actually is now because maybe that hill started sinking. Who knows? Leaning Tower of Pisa is literally leaning because the Earth is just crushing underneath it. Like, there are companies that make millions each year just trying to relift houses. All right, so little half a sticker. Now you need it. All right, so I'm actually going to move this for you guys because I don't like where it is. I know you don't. We're going to draw it. Yeah, we're going to put it in quadrant 3. All right, so what we're doing is we're starting into bearings. And bearings are, we did it last year as well, but it is pretty much the opposite of a reference angle. Everything deals in terms of north and south. All right, so when you do bearings, you always have a starting point O, origin. Okay, point of origin. Where did you start from? All right, then you go to some point P, way out here. Now, in order to get from O to P, you need bearings. So, it always starts with either north or south. So where would I have to start for this one? From the south. All right, so south, and then here's south. I don't know. What do we want to make that angle? That is way more than 7 degrees. 47 degrees, I will accept. All right, so then you put the angle itself, and then you have to put which way you went. Did you go to the east or did you go to the west? West. No, it doesn't. North is always north. North, south, east, west.
Never keeps on you off, but it's never keeps on you off.
Honey. Michael.
Which way are we looking at it? I looked up close.
North is always north when you look at it. North is always at the top. We don't switch around where north is. All right? Yes. Hey, squirrel child, can I keep going? Okay, thank you. So, now we got this one, which I don't think I gave you guys the stickers for it, but I would start writing that in while we get ready for stickers. Yeah. It's literally just which way are you going, east or west?
What's the point of that mnemonic device if it's not always true?
Honey, it is always true. It doesn't matter if you're in Australia or the U.S. North is still north.
No, I know north is still north, but like right now, if I'm looking at you right now,
Yes.
For the mnemonic device, I go never eat soggy waffles. But if I look over here, I go never eat soggy waffles. I don't actually know which way north is. What's the point of it?
But
North is a different direction every time. What's the point of how to remember it?
I'm going to bring you a lollipop. Can we move on?
I don't know.
Okay. Yes. Yeah, you don't need sugar. Because it's upside down. North is only a different direction because you put it on wrong. All right, so for this one, all I want you to do is tell me the bearing from O to P4. Nope. South 20 degrees east. South 20 degrees east. That's it. So yeah, you've got never eat soggy waffles. I learned north, south, east, west because there were a lot of Catholics, so people were like, "Oh, the sign of the cross, you can do it that way." I didn't care. News, N-E-W-S, like I don't care. Whatever you have to do to remember north, south, east, west. I just don't eat watermelon. All right, last one. No, it doesn't. There's no M in north, south, east, and west. Wombat? Why would we eat wombats? Wombats are adorable. They're...
Wombat excrete squares.
I did.
Wombats excrete squares.
Do we need to play the silent game like we did in 7th period? It was quiet. Alright, anyway, let me finish. So, a Boeing 777 took off from Nashville, off of runway 2. Do I care about anything in that first sentence? No, don't care. The numbers are just there to kind of throw you off. Now, it flew with a bearing of north 20 degrees east. So from north to my little blue line, that is 20 degrees to the east. Now, it flew for 1 mile. Alright? Pilot radioed in and went, "Yo, I want to make a 90-degree left turn. Is that cool?" Now, remember, that 90-degree left turn is from where he's flying. So that makes it a 90-degree. Alright? Homie kind of keeps trucking along, going northwest. He goes for another 2 miles. Now, what they're trying to do is they're trying to go from Nashville International Airport and figure out what is the bearing of that plane now. So what we really need is we need to find the entire angle down here. So, I don't know about you guys. I like redrawing it. So, what do you guys want to use? Yeah, I'd use inverse tangent. Yes. What was it? Like 63? Alright, now. Is that the bearing that I need, or is that just the entirety of that angle? Yeah, it's that whole stupid angle. So I gotta subtract off the 20 degrees from that bearing. So 63.43 minus 20, 43.43. So, how would you write that in terms of bearings? Ta-da, we're done. That's it. We'll use them tomorrow. Now,